Hey everyone, hope you had a great long weekend and welcome back. So this is going to be following up that POE that I released on Friday last week. And if you haven't gotten a chance to look at it yet, it's not a huge deal. I'm not going to be releasing anything tomorrow on Wednesday there. Uh, but if you haven't watched that POE video, just pause this right now, go and do that activity because it's going to uh, there's going to be the first part of this note is going to be based off of that. And if you don't really know what that first POE was about, then you're going to be a little bit lost here. So please just go and give that a watch and fill out the form because it does not take too long, and you get a completion mark for doing it. And it's probably the easiest mark that you can get in this course so far. You just have to watch a video and just participate in what the activity is. There isn't any knowledge that you need to have or anything that I'm testing you on. Just go ahead and do that. But right now, we're looking at electricity fundamentals. And I figured this would be kind of a more fun and interesting way to go into looking at the electricity unit, which is technically our physics unit at the same time, physics slash electricity. So we have three things that we're going to cover in this note, and it won't be too long. The first thing that we're going to be looking at is the POE explained. So I'll give you uh, kind of inside knowledge as to what's actually happening there. And I saw lots of really good lots of good submissions here. Some really well thought out uh, responses and explanations for what you initially thought was going to happen with the experiment. And yeah, I was really pleased. Really pleased. You guys are killing it. So, without further ado, let's actually figure out what the heck is going on with that PVC and the Pepsi can experiment, right? Okay, let's draw ourselves a little picture here, okay? And what I'm going to do, I'm going to choose white, and let's label this section though. So, oops, that's way too thick. That's thick with 37 C's. Okay, so PEOE, and what I usually call that one, like I call it PVC wizardry. Wizardry, because it's almost like I'm Harry Potter. And I would be Harry Potter if I had my glasses and shorter hair, but I can't get a haircut right now because of COVID. So it be like it be, you know what I'm saying? Okay. So POE explain. Let's draw some pictures here. So we had two things. We had the PVC rod, right? I'm gonna try my best to draw a kind of actually I'm gonna draw a little bit thicker, maybe with 3 C's thick. There's my thick PVC rod. And this was our PVC rod. And then we also had our Pepsi can. I'm going to butcher this drawing. I did not go to art school. Let's just do this. It's not any better, but let's label this Pepsi, and we'll label it just over here Pepsi can on its side. And from the responses I was reading, you folks have a really keen intuition on charges already, which comes as no surprise because you've been talking about them throughout public school, elementary school, private school, wherever you went before Yale. And we know, even from our chemistry unit, we know that we have a variety of different charges, right? We can label them. We can label these charges. So what are those charges called? Well, we have, what kind of charges do we have? So what types of charges do we have? Well, we can think back to our chemistry unit. What were the ones that we were talking about? Well, we had a positive charges, which was for our chemistry unit, we called those protons, and it stays the same over here where they're actually still called protons. We have negative charges, right? We have negative charges, and we called those electrons, and those are also staying the same. And we had neutrons. And we don't really have neutrons when we're looking at electricity specifically, but we should put them in here just to show that we can have neutral charges, right? And these we could just say that these were kind of like a neutral charge. Actually, I should have flipped those. Let's do that right now just to be consistent. So we actually have a neutral charge, and those were our neutrons. So when we're looking at this experiment, right at the start, both of these materials, the PVC rod and the Pepsi can, they were both completely neutral, we're going to say. And that's what mostly everything that you're going to look around you is. The coffee cup that I'm holding right now, it's a neutral object. There is no more, or there's not any more electrons and protons on it, or there's no more protons and electrons on it, right? There's a nice balance of both electrons and protons on there. There's nothing that's giving it a charge. If there was something giving it a charge, you'd be able to tell, right? Because if you picked it up or if you brought your hand close to it, you feel a spark. It's the same thing that happens when you rub your feet on the carpet, right? If you rub your feet on the carpet and you go and touch your buddy, you're going to feel a spark, and he's going to feel that spark too, right? Because what you've done, you've taken your feet or your body, which was neutral, and by rubbing it on the carpet, you picked up some extra electrons, and we have you would have zapped your buddy. So at the beginning, these were neutral. And to represent neutral, we don't actually have a symbol for electricity that we're going to use for neutral, but neutral just means that we have the same number of protons and neutrons, right? Same number of protons and neutrons. So if we were to represent this PVC rod as neutral, well, for every positive charge I'm going to draw on it, I'm going to draw one negative charge. And this is neutral. And we could say the same for the Pepsi can. I'm just going to draw them on the outside here. But just remember that these positive charges are all around the can. Same with the PVC pipe. They're all around the can. And they're neutral. But you might have noticed that I've left out one material here. We've left out the wool. So let's label this the experiment. And so what I'm going to do, I'm going to copy my PVC rod here. And instead of writing this as neutral, I'm going to do my best to draw my woolen sweater. So just pretend that's kind of like a sweater. So this is our wool sweater. Rubbing on PVC. And what that wool sweater is going to do, it's going to be happy. And we're not going to get into too big of a discussion as to why it's giving up these electrons, but what we can say for now is that when we rub this wool against the PVC rod, it is willing to give up a lot of electrons to the PVC rod. And so what happens is that this PVC rod, instead of becoming neutral, now it's getting a whole lot of negative charges on it. So much so that they're actually overwhelming the positive charges. There's not nearly as much negative charges, or there's not nearly as much positive charges as there is negative charges on there, right? So we could say that this is now negatively charged, and the wool transferred electrons to the PVC. So now we have something that is in balance. It's not neutral anymore, right? This is a negatively charged object. And what happens when we bring a negatively charged object towards a neutral object, right? We have the can up here. So let's copy and paste this can. Let's copy and paste the can. copy and paste the can. And I'm just going to draw just a few more charges here just to show that this is actually all around the can. Don't mind that it's a different color there. We got minus, 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 minus. It's still neutral. This is still neutral. But what's going to happen? What's going to happen when we bring this heavily negatively charged PVC? Let's keep it in the same color here. As we bring this negatively charged PVC closer, so let's think about this. Let's draw all those negative charges on there again. So we got a bunch. We got pluses up here. Not as much, but there's still some, right? And what we're going to do, what we did in the experiment, is we took this and we brought it close to the can, right? We brought it close to the can, and we want to know what's actually happening here. Well, what do you know about charges? Because you definitely have an intuition of already what's going to happen here with those negative charges and the negative charges on the can, right? We know, or at least we probably remember something about negative charges and a negative charge, or same charges do not like each other and they will repel. So what's going to happen? What's going to happen? Well, as we bring this PVC closer, what's going to happen with these negative charges here? Well, since there's so many of them on the PVC pipe, they're actually going to repel all the way to the far side of the can over here. All the way to the far side of the can. And you see, what do we have left over on this side? What do we have left over on this side? Well, it's only positive charges, right? And what do we know about opposite charges? Well, opposite charges like to attract. So let's make a little storyboard of this. So we have let's do this, and we can say this will just be a two-part storyboard here. And this could be, we'll say that this is step 1 and then this is step 2. So the negatively charged, let's say that instead, PVC pushes, we're going to say pushes in quotes because it doesn't really push, but in what this describes, it works for us, right? The negatively charged PVC pushes all the negative charges in the can to the far opposite side. And then what do you notice? What do you notice? Well, if all the negative charges over here, there's only positive here. So we have a buildup of positive on the side that are closest to the can, right? We have a buildup of, make this a bit smaller, we have a buildup of charge. And what's going to happen? Well, the can is going to start rolling towards the PVC pipe. Rolls. So we're going to call it an excess. An excess just means that there is a lot more of something. So with an excess of positive charge on the side closest to the PVC, we have more, we could say more interactions between positive and negative charges, which attract and moves the can closer to the PVC. So there's our kind of little storyboard here. It starts rolling as those charges get pushed off to the other side. So we see that, I'm just going to draw this over here. All negative charges pushed away. And then over here we have our excess positive charge. That'll be good for our purposes here. Okay. So, oops, let's get my mouse working here. That's the gist of what's going on in that PEOE. And if you've gotten it right, then hey, hats off to you. You did a wonderful job using the inquiry process here. But this leads nicely into our discussion of charges. So everything that we touch, everything, even our hands, even our the table that you might be working on right now, the computer, electricity running through the wires of your house right now, all of this is working on the basis of charge. All of this is working on the basis of charge. So let's start a new section here. So charges. And we talked above that we have two different types of charges. So we have a positive charge. Positive charge. And we have a negative charge. And usually with positive charges, if I'm doing it in shorthand, I'll probably just do this, like a circle with a plus sign in it, and for a negative charge, be a circle with a minus sign in it. And just like in that PEOE, we can have different materials that are going to have different types of charges. So we can look at materials. So uncharged material. So we can look at an uncharged material. These are always going to be, they're going to be called neutral. And when we say neutral, again, they have the same number of protons and electrons. And then we can also have a charged material. You can have a charged material, right? Because this is just going to be the opposite, where there is an imbalance. There's an imbalance of electrons and neutrons. Or sorry, electrons and protons. I'm going crazy. And protons. There's an imbalance of them, right? And usually this comes about from rubbing two materials together. So like, we could just say rubbing two materials together. And that's usually always different materials, right? You rub your hands together, you're not really going to build up a charge. But if you rub your feet on a carpet, your feet are a different material than the carpet, there's going to be a difference of charge there, and it's going to build up, and you're going to notice it, right? So, sorry, the phone call actually popped up on my iPad there and interrupted the video. So let's get back to it. We just have one last thing to cover here. So we're officially done charges. And we just need to cover the law of electric charge, and this won't take too long. This will not take too long. The law of electric. And the law of electric charge just has two stipulations or 2 points, and we'll write them down here. And the first point that the law of electric charge states is that, and we've seen this already in that PEOE, right? You already have a general intuition of what the law of electric charge is. And the first kind of main point for this is that opposite charges attract each other, right? Opposite charges attract each other. And what do you think the second one's going to be? Well, we're going to be talking about the other charge, which is like charges. Like, or we could say similar charges Instead of attract, they're actually going to repel. And repel, another word for that is just to push away. It does not like it. Repel each other. And this goes for all individual charges in a these two laws here applies to all charges in a material. So every single charge in that PVC pipe, every single negative charge is all affecting the negative charges in the can. It's not just one that's doing that, they're all doing that with a combined effect and pushing every single other negative charge in that balloon, or sorry, not in the balloon, in the can into the opposite direction, right? So it's all a combined effect of every single charge is behaving according to these laws, okay? And what I'm going to do now, I'm going to pass you off and for you to do the worksheet with this, and there's going to be kind of a cool simulation that you're going to be able to run on your computer. You should not need to have Flash or anything special. I just tried it on my computer and I don't have Flash, and I just clicked play and it worked okay. So before I leave you, I do want to show you something that is just another kind of really small demo here to show you how like charges repel and opposite charges attract each other, but we're going to mainly focus on that attraction. So we're going to look at how opposite charges attract, and you could do this again at home if you do have a PVC pipe or if you have a glass rod hanging around. Give this a shot. So I'm going to switch over the video here to me in my kitchen, and here we go. Okay, hey folks, welcome back to my kitchen. You saw my finger there. We're going to do a mini experiment here, and what we have is our PVC rod. We have my woolen sweater, and we have a stream of water here that hasn't been running too long. Don't worry, I'm not wasting water. And some delicious empty coffee there, but let's dig on in. So what I'm gonna do the same process. I'm gonna take this PVC rod and I'm going to charge it up, or I'm going to let my wool sweater here donate some electrons to this neutral PVC rod. I can promise you it's PVC and it's completely uncharged. I'm even touching it against all the surfaces so that it gets rid of its electric charge. And we're back with the normal PVC. What I'm gonna do, I'm gonna bring this close to that water stream. And you can make a small prediction right now. What do you think that water stream is going to do? Well, the water stream, is it positive, neutral, or negative? Well, when you take a drink of water, do you get a shock out of it? Usually not, right? So we can assume that water there has a neutral charge. So what I'm going to do, I am going to give this PVC rod a quick charge, and then I'm just going to set my phone down right here. Set it down right here, see if I can get a small bowl for it to sit against. And then I'm gonna bring it right near that water stream. So bear with me, I'm just gonna give the PVC rod a quick charge, and then let's see what happens to the water. So you ready? Here we go. Here comes the PVC. So you see how the water bends like that? So look at the stream to the far right. Watch how it bends. See? It's a kind of a cool effect, eh? So you can see that since the water has a equal number of protons and electrons, but our rod has more electrons than protons, the PVC rod is actually pushing all of those negative charges away, leaving only a few positive electrons left in that stream of water. And it's pulling it, since opposite charges attract, it's pulling it closer to the rod. All right, that's it. So please see the work there, and I wish you all a wonderful week. We will reconnect on Thursday. See you, everyone.